Hey, how's it going? This is Mr. Hernandez, and I'm going to be talking about ninja numbers. Um, some numbers that you've seen being written without it really being there, there's actually three numbers here. If you want to pause the video and think of what three numbers can I add around this X here that are not here. So the first one is this a 1 right here, a ninja 1. And this is in the spot of a coefficient. Another ninja number is, if you want to make it a fraction, you can add a ninja 1 as a denominator. Well, what cases would you need to add these ones? Well, you might want to add denominators if you're graphing a line, because you need rise over run. So you would add a 1. You might want a coefficient of a 1 if you're also combining like terms, like 1x and 5x. It sounds better than just x plus 5x. You could have the 1 there. And the last ninja is right here, and that's in the exponent. Okay, so that is some ninja ones that you've seen. So what are some other ninja ones that you've seen? Well, you've seen a ninja 1 if you've seen this before. There's actually a ninja. It's actually not a ninja 1, it's a ninja 2. So this here is called the index. And generally, if you see x squared and you want to undo or do the inverse of a square, you do this symbol, right? And you call it a square root. But really there's a 2 there as an index. It's just a ninja 2 because it disappears because it's so common to get that inverse. There's another case of, if you have a cube, in the inverse of a cubic is a cube root. But with cube roots, you always add that 3, right? You have to put that 3 there. Those are inverses of each other, which undo each other. But yeah, with the 2, you don't really see that. They leave it out because it's so common. Versus the 3, or the 4. You could even add a 4 for an index, or 5, and those numbers will be there. But the 2 is optional. Okay, and then the last one, and this is the one that you're currently on right now, is if you see something like log of 5. So what is log of 5? Well, if we put that into Desmos, well, actually, let me pick a better one. Let's do log of 100. So let's go ahead and put that in Desmos. So here I already put the log of 100 is 2. But notice I also put log base 10. So see, there's nothing here, right? There's a missing number here. But so some missing number to the second power is 100. Well, that's 10, right? This 10 to the 10 squared is 100. So this 10 here is actually our ninja number here with logarithms. Because base 10 is so common in logarithms that we leave it out. The same way we leave out the 2 on the radical symbol, the square root symbol. The same way we leave out these 1s because it's just so common. Yeah, if you ever see a log without a base, you can imagine it's just base 10. And again, you could see an X and there's 3 numbers around that. You can see this symbol here, and we always call it a square root, but we know there's a 2 there. And now if you see a log of any number, the base is going to be 10. Just one more, this is just extra, but if you see a log with a E, and let's just put a you know, some number there. This E is actually named for this guy named Euler. It looks like Euler, but his name is Euler. And it's a constant, pretty much like pi. So if you see, you know, pi is, you know, approximately 3.14. But if you put an E, if you put an E, that's the approximation of Euler's number, is approximately 2.718, and it goes on forever. It's an irrational number. So, yeah, when you see that, what you really will see is ln of 5, or whatever this number is, you know. So just like if you see a log without a base, it's a 10, base 10. Well, the same thing if you see ln. Actually, ln is the same thing as a log with a base e. But they call ln, you know, it's basically called a natural log. And natural log is basically a log with a base e. So this is just extra, but you know, there's another ninja number that you can see in the future if you take a, you know, math class later on. But yeah, that's it.